Hello. In this video, we will learn the concept of multiple pointers. Multiple pointers is a technique to solve problems in a more effective way. In this technique, what we do, we create multiple pointers or values that correspond to a given index or a position. So basically, whenever we have to compare two indexes or multiple indexes, okay, in that case, we have to basically apply this multiple pointers technique. This is very efficient for solving problems with minimal space complexity. When we have to use less space complexity, in that case, we use this multiple pointers approach. Now, let's understand how we can use this, how in means in what cases we have to use this multiple pointers approach. Let's take a case. And also what we will do, we will solve a particular problem using this particular approach. Understand how we basically implement it. So let's say we are dealing with a problem. Let's say that the problem is, let's say that the problem statement is, we are given an array, okay? And in that array, we have to find, in that particular array, we have to find a pair with given sum. We have to find that whether in that particular array there is a pair with given sum or not. That is what we find. We have to find. Let's say I've told you that the array given to us is 1, 3, 8, 10, 13, and 15. And let's say I have to ask that give me two numbers, means a pair of this particular array whose sum equal to 21. Whose sum is equal to 21. You will say, sir, 8 and 13 is a pair whose sum is equal to 21. You can say 8 plus 13 is 21. So this is what you can find. Here you can see we have to find two values. We have to find a pair. That means we have to use two pointers. We have to use two pointers. The first pointer, let's say I, will be point towards the first value, and the second pointer j will point towards the second value. This is a concept of two pointers. Similarly, we can have different pointers, and this particular concept is called the concept of multiple pointers. This is called a concept of multiple pointers. In this particular video, we will discuss the complete concept, how we can use multiple pointer in different ways. Now let's talk about different cases where we can use this two pointers approach to reduce the time and space complexity. We will discuss this problem surely, okay, in later in the video in detail also. But if we try the brute force approach of this problem, the brute force approach of the problem, so you can see we have to compare each and every pair. आप पूरी array में iterate करोगे, आप एक एक पेयर देखोगे कि क्या कहीं 1 और 1 plus 3 ना हो जाए 21, 1 plus 8 और 21 नहीं है, 1 plus 10, 1 plus 13, ऐसे करते करते आप सारे पेयर चेक करोगे. फिर 3 plus 8, 3 plus 10, 3 plus 13, then 8 plus 10, 8 plus 13, अब सारे पेयर चेक करो. And that will take, the brute force approach will take a time complexity of order of n square. And if you will follow this approach using a concept of hashing, we have discussed the frequency count method, the hashing, that is also another approach for this problem. That will also take a space complexity of order of n. So this will be the time complexity and space complexity for this particular problem if we don't perform it with two pointers. But if we will perform this particular approach using two pointers, so two pointers approach will give you a time complexity of order of 1 and a space complexity of order of n. That will be the time complexity and space complexity if we will use two pointers approach. But there is a basic requirement for two pointers. In mostly cases when we use two pointers or multiple pointers approaches, then the data should be in ordered manner. You can say sorted order. It should be in a particular order. It can be sorted order, just like binary search. Binary search is also a two pointers approach, a divide and conquer approach. And here also you can see the data is in sorted order. You can see in this case also, the array which we have taken is in sorted order. So we have to take the sorted ordered array. In that case only we can use two pointers approach. So it reduces our time complexity, it reduces our space complexity, but the data which we have to the data which we have to take is basically sorted, should be sorted. So that is what multiple pointers approach is. We will discuss some two different problems where we can apply this multiple pointers approach. We will discuss different problems where we can apply this particular multiple pointers approach. We will discuss the problem. We will solve the problem also. How we can solve the problem using multiple pointers approach. This is a problem which we are going to discuss now. And this problem is totally based on the multiple pointers approach. There are different approaches to solve this problem, but we will see how the multiple pointers approach can make this problem more effective in a more effective manner. How we can solve this problem in a more effective manner if we will use multiple pointers approach. If you will see the problem is key pair, where we are given with an array ARR of n positive integers and another number x. So we are given with our array ARR of n positive integers and another number x. We have to determine that whether or not there exist two elements in the array whose sum is exactly k. So that is what we have to find. We have to find two such elements in the array such that their sum is k, exactly k, not less than, not greater than, just exactly k. That is what we have to find. Now let's talk about the sample input output. You can see this is the array where we have this particular array. In this particular array, you can see that the value of n is 6, means there are 6 elements, you can see, and the value of x is 16. That means that you have to search for a pair whose sum is 16. You can see 6 is there, 10 is there. So 6 plus 10 is 16. Means there exists a pair, which is this one, whose sum is equal to 16. So we have outputted yes, there exists a pair. Here also you can see the value of 10 is, the value of x is 10. So we have to search for a pair whose sum is 10. And you can search here one thing, that 4 plus 6 is 10. So we have outputted yes, that there exists a pair whose particular, we can say, sum is 10. That is what we have to find in this particular problem. That is what we have to find in this particular problem, which is key pair. Now, let's see how we can solve this particular problem. So first, let's copy the sample test case which is given to us. Okay, let's copy it. So this is what we have discussed till now. You can see one thing here, that for this particular case, the array is 1, 4, 45, 6, 10, 8. And the value of n is 6 because there are 6 elements, and the value of x is 16 because we want a pair whose sum is 16. You have to find two numbers such that their sum is 16. Now, if we talk about the first approach, if we talk about the brute force approach for this particular problem, the brute force approach will be simply that we will have a nested loop for this particular array, and we will check for each and every pair of this particular array. First of all, what we will do, let's say we will have our I here, and j will start from here. It will check that whether 1 plus 4 is 16 or not. कि भाई 1 plus 4 16 है कि नहीं है, 1 plus 45 16 है कि नहीं है, 1 plus 6, 1 plus 10, 1 plus 8. अगला देखेगा कि क्या 4 plus 45 नहीं है, 4 plus 6, 4 plus 10, 4 plus 8. इस तरीके से एक एक करके सारे पेयर्स को चेक करेगा. And what will be the time complexity of it? It will be n square. Maybe you are confused. Let's implement this thing. Okay, let's implement this particular part. Okay, so you can see one thing here. We have an array, we have a value n, and we have a value x. X is basically the sum. Okay, that we have to find. So what we will do, I am saying is just take a for loop, which will contain a I. I will be basically our iterator. Okay, and we'll have a nested loop of j because we want pair. We want two elements. Okay, this is how we will do. Okay, now if ARR of I plus ARR of j will be equal to x, whenever we will get that the value of our ARR of I and ARR of z means we have two elements, that is the pair. The first element is where I is pointing, and second element is the first element. Here comes the second element. Okay, okay. So whenever the sum of the first element and the second element means a pair is equal to x, that means we have got our answer. So we will return 1 in that case. You can see it is saying that if this is the case, return 1, boolean or 1, true, false, anything. And if for all the pairs this doesn't exist, so return 0. Okay, return 0. Let's run this thing. Let's compile this particular thing. Okay? You can see, yeah, the answer is fine. The output is fine. Okay, you can see in this particular output should be yes. Instead of this, if I will place here, let's say 160. So for 160, output should be wrong. Why? Why it should be wrong? Because 160 is not present. If I will ask you that tell me a pair which is giving you some 160, you will say no such pair is there. No pair can give you a sum of 160. So it will give no, and that is also the right answer. But if you see the time complexity of this particular approach, the time complexity will be order of n square. The time complexity will be order of n square. Okay. Now, can we optimize this? Yes, we can optimize this using the two pointers, the multiple pointers approach, or we can say two pointers because here we will use two pointers only. So before doing that thing, before finding the two pointers, as I told you, two pointers approach needed a sorted array. So we will first sort the array. For that we have a function called sort JavaScript. That function will be used to basically sort the array. So what I will do, after we will sort, the array will become like this: 1, 4, 6, 8, 10, and 45. This is how our array will become after sorting. Now what we will do? Now here comes the concept of two pointers. After sorting, what we will do? We will take two pointers, which is I and j, which is I and j. I will point towards the zeroth index. So let me write the indexing also. 0, 1, 2, 3, 4, 5. So I will point towards zeroth index and j will point towards the last index. Okay, last index, or you can say n minus 1. If the size is n, so it will be n minus 1. Okay, now from here the comparison will begin. What we want? We want that the element at I and element at j should be equal to the sum or x. If this is the case, we will return 1. That is the obvious thing. But there will be one more thing. What if the sum of ARR of I plus ARR of j less than x? What if the sum is less than x? If the sum is less than x, so what we want? We want to increase the sum. We want to increase the sum. So for that, what we will do? We will change the value of our I and j point. अभी I हमारा 1 पे पॉइंट कर रहा है, j 45 पे पॉइंट कर रहा है, उसकी वैल्यू में चेंज कर दें. ऐसा चेंज करें कि सम बढ़ जाए. तो किस केस पे सम बढ़ेगा? अगर हम लोग इस j को यहां से यहां कर दें, if we just decrease the value of j, the sum will be reduced. अभी क्या था? 1 plus 45 46 था, अब वो 1 plus 10 11 हो जाएगा. ऐसा नहीं करेंगे. What we will do? We will increase the value of I. And when the sum is greater than x, so we will decrease the value of j. We will decrease the value of j so that it can be done. So that now sum can be reduced because currently it is greater. Now these are the three conditions that we have to apply. Let's see. Here the sum which we were wanting means the x is 16. So currently our I is 1 and our j is 45. Our I is 1 and j is 45. You can see ARR of I plus ARR of j is 46, which is greater than our 16. So this case will be done. This third case will be considered and it will decrease the value of j. So now j will be decreased and now it will point towards 10. Okay. Now the sum is 1 plus 10, 11. Now sum is less than 16. So I plus plus will be. So I will be increased and will be here. Now again the sum is 4 plus 10, 40. It is less than 16. Again we will increase the I. So the sum should be increased. Again I will be here. Now you can see that ARR of I is 6, ARR of j is 10, and the sum is equal to 16, what we want. So we will do this thing until we get the answer. And if for all the conditions, means when we will do this till I and j will not meet. Whenever I will j will meet at a point, that means sum is not present. Let's say if I will make here, let's say if I make here 15. Let's say I will make here 15 instead of at this place 16 will be greater than 15. So we will reduce j. J will be here. And now 8 plus 6 is 14. So we will increase I. When we will increase I, this I and j will point towards same path. Now means 15 is not present. We cannot get sum 15 in this particular problem. This is what we have to do. This is how we can solve this particular problem. This is the exactly the approach what we want in this particular problem. Okay. So now let's try to implement this thing. How we can implement this given problem to check whether there exists a key pair or not. Key pair is what? Whose sum is equal to the x given to us. Whose sum is equal to the x which is given to us. Let's first again compile what we have discussed. So first of all, what we have discussed, we were given with an array of size n and the array elements are given to us. The value of x is given to us, which is 16. Okay, so the value of x was given to us. Okay, now first of all, the first step is, let me write the steps here. Okay? The first step is to solve the array. First of all, what we have done, we have sorted the given array. We have sorted the given array. Okay. After sorting what we have done? After sorting the particular given array, what we have done is we have taken 2 pointers. You can see if I will just erase everything, if I will just rub everything, you can just recall one thing, that initial values of our pointers was, I was here and j was here. So we will have 2 pointers, I and j, and the value of I will be 0 and the value of j will be n minus 1. This is the initial case. This is the most initial case. The most initial case. Okay. Now, Third thing is we have these two values. We are considering that the sum of these two values should be equal to x, what we want. Okay. So whenever the sum will become equal to x, we are just returning. And till when we have to do this thing? We have to do this thing till fourth case is till our I is less than j. Until while our I is less than j, till then only we have to compare these three conditions that are written to it. So if the given sum, the sum at elemental I and elemental j is equal to the required sum, which is x, we will return 1. But if it is less than x, so we want to increase the sum. We will do I plus plus. Increase the value of this I pointer. And if the sum is greater than x, so we will decrease j. We will make j minus 9. Okay. This will be the case. Now, so this was the thing. And the fifth is just implement three cases that are written here. This is the approach what we will solve to basically code this particular problem. Let's code it. Let's code and let's understand how we are going to solve. Okay? So let's remove everything. And first of all, as I've written, sort the array. I will do arr.sort, and that will sort the array for us. That will sort the given array for us. After that, we will take two variables I and j. So your I minus j will be taken. I will be equal to 0 and j will be equal to n minus. So I will be equal to 0 and j will be equal to n minus 1. That is the next case that we have to consider. Okay. Now we have I less than j. Means till I is less than j. Till I is less than j, we have to do the particular thing. So while our I is less than j, till then we have to perform the three conditions. And the three conditions are written here. These are the three conditions that we have to perform. So the first condition is if ARR of I plus ARR of j is equal to x. So we will return 1. That yeah, we have got our answer. Okay. Else if ARR of I plus ARR of j, if ARR of I plus ARR of j is less than x. This was the second condition. If it is less than x, you can see here. So I will make I plus plus. And in the else part means it is basically when ARR of I plus ARR of j will be greater than x. In that case, we have to do j minus. These are the three conditions that we have to implement. And now, after this, if for the complete loop, भाई मान लो हम लोगों ने पूरा लूप चला ली, चेक कर ली I और j लेके, दोनों मिल गए एक जगह पे, अभी भी हमें sum नहीं मिल रहा है. We have not got the required sum. That means that sum doesn't exist. This is the case. And after this, we'll have return 0. Why return 0? Because if the sum is not present, if this one will not be returned, so वो program क्या करेगा? वो 0 return कर देगा. It will return 0. It will return 0. This means that sum is present, and this means sum is not present. This means sum is present, and this means sum is not present. It is not present. Okay. And now let's compile the code. You can see for 160 the answer is no, because as I told you, for 160 the sum is not present in this particular array. If I will make it 16, for 16 it was present. For 16 it was present. If you will see for 16, you can see that the sum is present. Yes, the sum is absolutely present. It is present. And this is what we have to do. Okay. Now let's talk about the time complexity of this code. If we discuss the previous code, which was the brute force approach. So for brute force approach, you can see that our time complexity was order of n square and our space complexity was order of 1. Means our space complexity was optimized, but time complexity was not optimized. It was order of n square. Okay, and here what we are doing, in this particular case, what we are doing, we are optimizing it. And in this particular case, you can see one thing that if I will write this two pointers approach, so in this case, the time complexity is order of n log n, and the space complexity is order of 1. Let's see how. Let's see how. So you will say, sir, this how much, what will be the time complexity of this while loop? So you know that the two pointers are just iterating inside the array and only once. So that means that their time complexity will be just order of n. Time complexity for this loop will be just order of n. It will not be greater than it. But if we talk about that, there is a sort function and sorting takes this sort function, this inbuilt sort function will is basically will take order of n log n. This takes the order of n log n. This sorting takes the time complexity of order of n log n. And this is basically the actual time complexity. Because according to our phenomena, if I write time complexity is equal to order of n plus n log n. Okay. This n is for the while loop, and this is for the sorting. So this is greater one. Eventually, it will be order of n log n. At the last, it will be just order of n log n. This is the case. This is the given case to us. This is the case given to us totally. Totally. Okay. Now, you can see one thing, we have optimized our time complexity from n square to n log n. But the space complexity is the same. It is just order of 1 and 1 only. But the time complexity is reduced. Because here also you can see we have not used any extra space. Any extra space is not used. So that means that we have optimized. This is how two pointers approach can work as I've told you. It basically is very efficient for solving problems with minimal space complexity. You can see we have not even used extra space. Extra space is also not there. And by using just some pointers, by creating some pointers who are corresponding to a particular index, you can see we are doing this particular thing. We are doing this particular thing and we are finding the answer, and we have optimized our brute force approach to a two pointers approach. This is how the two pointers and the multiple pointers works, and it optimizes our solution. Now we will discuss one more example so that you can get more clear of that. You can see in this case we have taken two pointers. One is from the start of the array and second is from the end of the array. But that is not the case. Maybe both the pointers are from the start. Maybe one is at the middle of the array. Just like in binary search, if you have learned binary search, there's a mid pointer also, which is pointing towards the mid of the ing, mid of the considering array. That is also a case. That is also we can consider. So now we will consider one more problem, which is using the multiple pointers approach. Now guys, just like we have discussed it for this particular case where we have to find a sum whose value is basically given as 60. We can also have a quite change in the problem. The problem can also be like we have to find a pair, means a pair whose sum is 0. That can also be the problem. This can also be the problem statement. In that case, we have to do nothing, just replace this x with 0, and here we will make it 0. But whenever the number is equal to 0, we have to return 1. If it is less than 0, make I plus plus. If it is greater than 0, make j minus minus. It will be a very obvious case that we will discuss. Now, if we will talk, if we will try to perform a different problem, let's try to solve a different problem which is similar to this only, but is quite different from what we are basically targeting. It is quite different from it, which is some pair closest to x, which is some pair closest to x. This is the problem. In this particular problem, you can see one thing that it is asking you, it is saying you that we are given with a sorted array. So the array is already sorted. Okay. We have to find a pair whose sum is closest to x. Now let's talk about this. You can see one thing. This is the array. There are different numbers in this array. There are different pairs in this array. But the value of x is 54. So we have to find such particular pair whose sum is very close to this 54. Whose sum is very close to this 54. You can see that here it has operated 22 and 30. Means 22 and 30 is a number whose sum is very close to this particular case. Okay. This is what we have to do. This is what we have to do. Now, let's take this particular question and let's see how we can solve it in a more efficient way. So this is the array given to us. You can see here, this is the array given to us. Okay. In this array, if you will see one thing that, in this array, you will see one thing that it is already sorted. There is no need to sort this array. The value of x is 54. That means we have to find a pair whose sum is close to 54. Whose sum is very close to 54. That is what we are wanting. That is what we want from this particular array. Okay. Now, let's discuss one thing. Let's discuss how we can solve this particular problem. Obviously, we will be going to solve the problem using this approach only, which is a two pointers approach. We will have our I pointer at the start and j pointer at the end of the array. There are 6 elements in the array. We have our I pointer and we have our j pointer. That will be our case. Now, the next case will be, again, the operations will be very same. Just like we have written the different 3 conditions for our problem, which we have discussed earlier. Here also we will write 3 conditions. But there is a quite change. Because here we don't want 2 numbers. Here what we want, that the 2 numbers, which is ARRI plus ARRJ, should can be equal to 54 also, but it should be close to x. It should be close to the number which we have. Let's take example. If we take these two numbers, the sum of this will be 57. The sum of this will be 57. This is also a pair whose sum is 57. But if we take these two pairs, its sum will be 52. If we take these two pairs, which is 10 and 40, its sum will be 50. There will be multiple pairs. If I will just find the pairs of this particular array, so what we will do? The first pair will be 10, 22. Let me write all the pairs. 10, 28, 10, 29, 10, 30, 10, 40. Similarly, 22, 28, 22, 29, 22, 30, 22, 40, 28, 29, 28, 30, 28, 40, 29, 30, 29, 40, and it is 30, 40. These are the pairs. These are all the pairs which are possible from this particular array. If we find a sum of it, it will be 32, 38, 39, 40, and 50. Similarly, here it will be 50, 51, 52 and 62. Here it will be basically 57, 58, and here it will be 68. Here it will be 59, it will be 69, it will be 70. This will be our all the pairs. I have written all the pairs which are possible in this particular array. You can see we have to find a pair which is very close to this 54, which is very close to this 54. Basically, close means the difference between the pair sum and this number x should be very less, should be as minimum as possible. You can see that this 52 is a number which is very close, which is closest from 54. We have 57 also. Let's consider 57. The difference between 52 and 57, 54 and 57 is 3. But the difference between 52 and 53 is just 2 only. So 52 is the only number with minimum distance, with minimum difference. That means it is most closest to this 54. And this is what we have to find. This is what we have to find. Okay. I hope you have got this particular approach, how we are doing this thing. Now let's see how we can solve this problem. Let's see how we can solve this particular. So obviously, as we know, we are considering there we have another counter which is called difference. So here we don't have to just compare the sum of pair with x, but we have to also compare it with the difference. We have to also compare it with the difference of the number. The difference kya hai? We have to also compare that thing. And we will take that pair whose difference is very minimum, whose difference is minimum possible. We will take that pair. That is our approach that we are going to implement, that we want to implement. Okay. So see one thing here. Just see one thing that here this is the array that we have. This is the array that we have. Now let's have these two pointers I. So the two cases will be as it is. The two cases will be like that, but we will have a different case also. Let's see what is that. First of all, what we will have one thing that we will first find the difference of this sum. So let's call it pair sum. What is the pair sum? Pair sum basically ARR of I plus ARR of j. This will be the pair sum. Now we'll find the difference between the pair sum and our value x. So the difference between the pair sum and the value x, it will be an absolute difference. Means if pair sum is greater, so it is pair sum minus x. If x is greater, it is x minus pair sum. That is a normal absolute difference. Okay. Now the next case is very important. Is the next important case. Okay. So the next important case is that we are going basically, which we are going to implement is that currently our difference will be very large. It will be very large. Let's say infinity, very max value. Numbers dot max value that we write in Java, no? It is infinity. Okay. Now what we will do, if our current difference, let's call it current difference. Let's call it current difference. If our current difference will be less than our last difference, मतलब अभी जो हमारा सम का पेयर है उसका जो डिफरेंट है एक्स से वो कम है, that is not, this is the pair that we want. That means this is the pair that we want. So in that case, what we can do, in that case, what we will do, we will change the value. We will change the values. In that case, what we will do, we will change the values. So I will make the difference equal to current difference. And let's say we will have two variables, let's say A and B. This A will contain the number, this A will contain the number, which is basically where our I is pointing, and J will contain the number where B is pointing. So our A will be equal to ARR of I and B will be equal to ARR of J. इसका मतलब क्या हुआ? इसका मतलब ये हुआ कि भाई जो A और B हैं, जो A और B हैं, वो नंबर्स हैं जिनका सम मिनिमम डिफरेंस दे रहा है. Okay, maybe it's quite confusing. Let's implement this problem so that you will get it more clearly. Let's implement it. Okay, you can see here we have the ARR. So let's also have a number n. We will also have a number n. So where we have to perform the basic output. Okay. So first of all, what we will do, as we have discussed, first of all, we will have the value L, that will be 0, and R, that will be n minus, just like what we have in our normal case, just like what we have in our normal case. Okay. Now the next thing, the next and the most important thing that we have to discuss. The next thing is that we will take a difference. Okay, so sorry, I am taking n. That's it should be let. Okay, or we can take as variable also. So I was just confused between C++ and this because I basically code in that also. So it's variable, and this is the thing that we are basically considering. We will also take a difference. As I told you, the initial value of a difference is infinity, or you can say the maximum value, the most maximum value that we can get. And if we discuss how we can find the maximum value in Java, it will be number dot max sorry max value. It will be number dot max value. Okay. Now after this, what we will do, we will have a simple while loop, that is L is less than R. A simple while loop will be there. Okay. Now, now a simple while loop will be there. Now, if the first case, if so, we will have the two cases which were written here. You can see these two cases. These two cases will be the same. इसमें कोई भी change नहीं होगा. Okay. That two cases will be we will have here. Okay. So let's write if ARR of L. So I am taking here L and R, left and right pointer. We can say not A, I and J, and R. If it is greater than X, so what we will do? If it is greater than X, we will make R minus 1. And in the else case, if it is not greater, we will make L plus. That is a very obvious case that is written here. Okay. ये तो हम लोगों ने पिछले क्वेश्चन में पढ़ाई हुआ है. अब देखो नया क्या है. नया क्या है, यहाँ आपको इक्वलिटी देखनी नहीं कि इक्वल है कि नहीं है. इक्वलिटी देखनी नहीं. यहाँ हमें क्या देखना है, डिफरेंस सम. So first, as I told you, we will find the pair sum. We will find the pair sum. So let's find the pair sum. It will be where pair sum is equal to ARR of L plus ARR of R. But just I am taking L and R instead of I and J. That is the only case. Okay. Now, guys, now what I will do? Now what I will do? After this particular case, what I will do is that I will find a current difference. So this is our global. This is our, we will have a current difference also. So let's take a var current difference, and that current difference will be equal to mat.abs because we have to take the ABS. Okay, ABS value of that means absolute difference of this pair sum and the value x and the value x. This is the another case to consider. Okay, we have got the current sum, and this is the thing that we will do. So we will have two variables that is also given a and b. So if our current difference, if our current difference is less than the difference, in that case we will take that yeah, this is the pair which we are searching for. हमें क्या करना, हमें सबसे कम डिफरेंस का पेयर सर्च करना ना. जब हमें कोई कम डिफरेंस मिला, हमने वो पेयर स्टोर कर लिया, हमने डिफरेंस की वैल्यू भी अपडेट कर दी. वो पेयर कहाँ स्टोर हुआ, पेयर कौन सा है, ARR ऑफ L और ARR ऑफ R. उसको हमने एक वेरिएबल L A में और B में हमने ARR ऑफ L R ले लिया. अब जब पूरी लूप चल जाएगी, एट द लास्ट हमारे A और B में क्या होगा, वो पेयर होगा जो बहुत क्लोज होगा, इसका सम बहुत क्लोज होगा X से. तो हम लोग उसको नॉर्मली console.log कर सकते हैं that A and that is the case that we will be doing. तो हमने सबसे पहले क्या किया, तो जो बेसिक हमने लास्ट में किया था, तो हमने बेसिक चीज की थी लास्ट वाले प्रॉब्लम में, वो हमने देखो यहाँ पर भी. ओके, तो एक काम करते हैं, let's write in so that it will be more clear to you. Let's write in this thing. Let's write in this particular approach so that it will be more clear how we have to solve. how we are doing the thing. Let's make it more clear. Okay. Okay. Now, so initially what I will do, we will take a difference. The difference is initially, let's say, very maximum value. Let's say infinity. I'm writing it here, okay? We will have 2 pointers, I and J, or let's say L and R, because we have taken L and R resistance. So let's say L and R. And X, R X is 54. You can see that first of all, this condition is always run. ये condition हमेशा चलेगी. हमेशा. ठीक है? So now, first of all, it will find the pair sum. So the pair sum will basically equal 10 plus 40. Now I will find the current difference. Current difference is basically pair sum is 10 plus 40, it will be 50. So current difference will be basically x is 54, current sum is 50, it will be 4. 54 minus 50, 4. Now you can see the other case कि हमारा current difference है वो कम है इससे. If current difference is less than difference, so what we will do? We will first update the difference. So our difference will be updated to 4. And then we will have two values more, A and B. A में क्या आ जाएगा 10 और B में क्या आ जाएगा 40. अभी हमने एक ऐसा पेयर फाइंड किया है जिसका सम जो है बहुत क्लोजेस्ट है x से. अब देखो ये सम जो है लेस है, सम जो है ये छोटा था ना x से, 50 was लेस. तो लेस होता है तो क्या करते हैं, लेस होता है तो आगे बढ़ा देते हैं I को, L को. That will be here. Now you can see the pair sum is, now if we will do, let's update the values. Now the pair sum will be 22 plus 40, means it is 62. Means it is 62. So if it is 62, you can see its difference will be something 8. But this 8 is greater than this 4. It is greater than this particular. So this will not run. This condition will not run. It will just go on and it will check that the pair is 62. So because the pair is 62 and the number x we are finding is 54, that means our sum is greater. Our sum is greater. So because it is greater, so what we are doing, if it is greater, we have make r minus minus. R will be minus minus and we will have this r here. Okay. Now you can see one thing. Again, you can see it is 22 plus 30. 22 plus 30 means here we will have 30 and here will 22 and this will be also a bigger. 52 will be there. If it's a difference, 54 and 52, difference will be 2. The current difference will be 2 only. It is only 2. Now you can see again, the current difference is less than difference. Current difference is less than difference. तो यहाँ पर भी 2 हो जाएगा. यहाँ पर भी 2 हो जाएगा. And again the value of A and B will also be updated. A और B की वैल्यू भी तो अपडेट होगी. A हो जाएगा हमारा 82 और B हो जाएगा हमारा 30. Okay. 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 Now again the thing is कि जो 52 है that is less than 54. So means again you have to increase the value of L. फिर से L बढ़ जाएगा. तो हमें ये सब बिल्कुल लास्ट तक करना है. मे बी अभी और अच्छा सब मिल जाए. जरूरी नहीं कि हमारा आंसर हमें पता यही है, तो हो सकता है आगे और अच्छा सब मिल जाए तो और क्लोज हो 54 से. ओके. So now again you can see one thing that 28 plus 30 will be there is 58. The difference will be 4. But the difference is greater than this. So we will again go. And because 58 is greater than 54, again R will be different. Because क्या है? जब वो बड़ा है तो R छोटा हो जाएगा, R minus minus हो जाएगा. Okay. So R minus minus will be there. R minus minus will be there. So R L was here, now R will be here. And again 28 plus 29 will be 57. Now difference is 3. Again difference is greater than difference. अभी भी वो difference से बड़ा है 2 से. अभी हम लोग कुछ नहीं करेंगे, अपडेट कर देंगे. तो अगेन 54 बड़ा है 54 से 57 बड़ा है, R माइनस माइनस कर देंगे. तो हमारा जो ये R है that will be here. That will be here. अब देखो L and R meets. So our while loop was just when L and R was less, L was less than R. This will stop and our answer will be at the last 22 and 30. Means 22 and 30 is a pair who is very close to this 54. You can see that is our answer also. And then we can just log it. So this is a problem which is closest sum to a particular value. So इसके पहले हमने समझा initially what we have learned we have to find a pair whose sum is equal to whose sum was equal to whose sum was equal to the value which is given to us, the x which is given to us. But here we have to find a sum which is close to x, which is very close to x. Okay, so this is what we are going to do. And you can see again the time complexity for this code. If we will do it in the brute force approach, we have already discussed. The brute force approach will take for this problem order of n square time complexity. Space will be order of 1 only for both the cases, for the 2 pointers case also. But the time will be same. It is optimized, but time will be order of n square. If we do in this way, the time will be order of n only, because here even we don't have to solve the pair. The array is already sorted. We are assuming that array is already sorted. We are just iterating through it, and we are getting the answer. So this is what we have to do. This is how we can solve our question more effectively, and that is what this multiple pointers approach is. I hope now you have got a complete approach at what is multiple pointers and what is the thing. I hope that you have got the complete approach of multiple pointers. Okay. Similarly, we can solve different concepts of multiple pointers. Now let's have a small recap. Let's have a small recap of what this multiple pointer is exactly. So you can see that we have taken some problem. Multiple pointers means we can take different pointers, different iterators basically. Just like in a for loop, we have a single iterator. Let's say int I, int j, whatever we take. But in multiple pointers, we will have different multiple operators, multiple pointers, multiple iterators, which basically correspond to a particular index, particular position, and that. And then they move forward. You can see they move forward based on a certain condition. You can see. First of all, what we have done, we have first taken the iterators, the pointers, and then based on the condition, we are moving it. So always a pointer and condition is a very efficient part in its important part. Okay. For this particular case, for this particular multiple pointers approach, it is very effective for solving problems. It is very effective for solving problems with minimal space complex. Because you can see in all the approach, usually what happens is that when we decrease time complex, you can see here we are decreasing time complex. It is decreased. Usually what happens is whenever we decrease time complexity, our space complexity increases. That is what happens usually. But here you can see space complexity is also just constant. It is also not increased. And time complex is also now linear. That is why this two pointers approach is very helpful in solving these type of problems. It is very helpful. Okay. You can see first of all we have discussed a problem which was pair with given sum. In that problem also you can see that we have just taken an array and then the pairs, and then we have just counted the sum of them, that if the sum of them is equal to a given number or not. That we have solved using this particular, but we have solved it using n log n because we have to solve the array. If the array sorting was not there, the time will be just order of n instead of this brute force approach. Then we have checked it for this particular thing. Then we have checked this for this thing that n, x, and arr. That if the given array is given to us, we have to find a pair with given sum. That was the same question we have discussed about the brute force approach and its two pointers approach. Then we have solved a problem which was pair sum closest. उसका थोड़ा सा वेरिएशन था. अब इसी से आप कर सकते हो pair sum equal to 0, pair sum equal to x, pair sum closest to x. There can be different problems which can be solvable by this particular approach. ये बेसिक अप्रोच हो सकती है हमें प्रॉब्लम सॉल्व करने की. इससे आप देख सकते हो कि हमारा जो टाइम कॉम्प्लेक्स है कितना इफेक्टिव हो गया. हमने कितने अच्छी तरीके से हमने प्रॉब्लम को सॉल्व कर लिया विदाउट यूजिंग एनी एक्स्ट्रा स्पेस. एंड दैट इज व्हाई दिस टू पॉइंटर्स अप्रोच इज वेरी important. So this is all about two pointers. I hope you have loved this video. Thank you.